welcome to our second lecture on principles of programming languages. In the last lecture, I explained you about the basic structure of a digital computer, and today we will explain that how this block diagram relates to a programming language like C. Now to understand that, let me write one C program. Let me write one C program. You don't need to understand all the steps of the C program right now, because I will be explaining you step by step in the later lecture. But for the moment, we will just try to relate the two things. Now, don't worry about the things which I am writing here. I will explain you everything. Don't worry that what are these things. In the first line, I have written hash include stdio.h. In the next line, I have written void main, then opening braces, or you can call a second bracket, int a comma b, then semicolon. Then I will write something called printf, enter two numbers, close the first bracket, put a semicolon. Then you write scanf %d ampersand a ampersand b. Now int sum equal to a plus b, printf the sum is %d comma sum, close bracket, put the semicolon, then close the second bracket. Okay, now this is the very basic C programming language. I will repeat it for you. Hash include stdio.h, then next line void main with open first bracket and then closing it, closing the bracket, then starting the braces, that is the opening a second bracket. Then I am typing int a comma b semicolon, printf within bracket and within quotes, enter two numbers, put a semicolon, scanf %d within quotes, then ampersand a comma ampersand b, finally int sum equal to a plus b, and in the last line I have written printf the sum is %d comma sum. Okay, and I have closed the second bracket. Now many of you may have understood that this program is taking two numbers a and b and then printing the sum of these two numbers. See, I have taken two numbers a and b, then performing sum equal to a plus b, and then printing the value of sum in the output. Now see, this relates very much to our block diagram. How does it relate to our block diagram? I will explain step by step. In the block diagram, we all know that user is giving input to the computer and it is coming to the RAM. Here also see, same thing is happening. I am giving two inputs, A and B. Now question may arise, then what is this int? You will understand this in a few moments. Now, how will the user know that I want two numbers to be entered into the computer screen? So, I am using a standard input function like printf to take two numbers from the user. That is why I have given printf enter two numbers. Now, printf is a function. What is a function? Again you will understand in the later lectures, but for the moment remember that if you want to print something onto the screen, we use the printf function. Now here I want two numbers to be entered by the user, so I have written printf enter two numbers, and whatever is written within the quotes is taken as a string. So enter two numbers will just be printed in your monitor, and it will be a string, and it will be typed in the same way as it is written here. Enter two numbers. Now the third step is the most important one, because between step 1 and step 3 you can relate this thing, that is how the input unit is sending the data into the primary memory of the computer. Now scanf %d means, you will understand. See, A and B are two input. Now through int I want to refer to the computer that A and B are integer variables. Why I require this? Suppose you want to book a hotel in some city. You have dialed your phone. Whoever person is present in the hotel, the receptionist, she just takes your phone call. And what is the first question she asks? She asks that, okay, on which day are you coming? How many rooms you require? Now, why does she need these informations? Because unless and until she knows that how many of you are traveling to that place or booking that hotel, she cannot accommodate rooms for you. Similarly, if I don't declare that how much of memory is required for the computer to store the input values, that must be specified to the computer. Otherwise, like the receptionist asked you that how many of you are staying or how many rooms you need, she can't accommodate. On a similar note, the computer cannot accommodate unless and until it knows that how much space is to be allocated for A and B. Now, for your knowledge, A and B are variables. Variables which are capable of holding different types of data. That is why they are variables. Now, here A and B variables are of type integer. Do you know integer? That is 1, 2, 3, 4, 5, 6, 7, 8. All these numbers are integers. Now, A and B are integers means, from theory, we know that whenever the variable is of type integer, the computer will store 4 bytes of data in the memory. Now, for A, the RAM will allocate 4 bytes of memory. Again, for variable B, the computer will allocate 4 bytes of memory. Now, they are very much sure that I have to allocate 8 bytes of memory for these particular variables and their values. So, by this step, memory is allocated. Why %d? Because A and B are integers. So, whenever the variables are of type integer, you have to put here %d. And what does ampersand A and ampersand B means? That means the address of variable A. Again, ampersand B is address of variable B. That means how will we refer the values later unless we don't know the address? Now, consider that I have gone to the hotel. Now, there is some problem. Now, when I call my neighbors or my parents or my friends that boss, please take me out of the trouble, I am stuck in a hotel. What is the first thing they will ask me? That where are you currently located? What is your address? Otherwise, they can't come and help me. Similarly, when data is to be retrieved from the RAM by the CPU, okay, without knowing the address, they cannot refer the data already stored in the memory. So, they must be knowing the addresses. That is why when the variables are stored and allocated with 4 bytes of memory each, their address must be also be specified. That where exactly those values are stored. Now, consider here what can happen with this step. Suppose I have given two variables 2 and 4, okay, as input 2 and 4. Now in step 3 what happens? variable 2 is stored in some place in the memory, and what will be the size of this? 4 byte. Why? Because it is integer. Again 4 is located in some other place. This will again take 4 bytes. And remember, this may be contiguous, that is, this location and this location can be in continuous places or may not be in contiguous places. They can be in any place within the memory, but in normal circumstances they are side by side. Okay. So this is 4 bytes, this is 4 bytes, and the address is say 00. Now the location of these two is 00. So how is it specified? Through ampersand. And the location of B is 10. Now how is this address specified? Through ampersand B. Now after step int a comma b, printf enter two numbers, scan a %d, ampersand a and ampersand b. This whole thing is done. That is 2 and 4 are being given input. They are of type integers. They are being stored in the memory at locations 00 and 10, and each of them are taking up 4 bytes of memory in the RAM. So is it relating to the same way? I hope yes, that you are relating my talks, and you can understand that how the programming is directly related to the block diagram of a computer. So let's move to step number 4. What happens? See, now the value of a plus b is being added in the arithmetic logic unit, because RAM knows the addresses of variable a and b, that is 2 and 4. So whenever the memory read operation will be performed by the CPU, control unit knows that where exactly in memory I will refer to retrieve 2. Is not it? Because the control unit, while sending the signal, it must know that 2 is located in location 00. Now again, this is another utility of allocating the address, because otherwise control unit will not know that from where I will retrieve the value of the variables a and b. So when control unit generates signals, it generates memory read signal, and through memory read signal it's making a reference to the location 00, and variable 2 is retrieved and stored in the CPU register. Now again similarly 4 is being referenced to at location 10, and it is again stored in some other register. So after this, what happens? Here arithmetic logic unit will perform this task, a plus b. So a plus b is performed here, means 2 plus 4 is performed in arithmetic logic unit. 2 plus 4 is already performed. Now then what about this variable sum? I didn't declare it earlier, so I have to declare it now, because otherwise where will be the sum of 2 plus 4 be stored? Because now ALU has calculated the value, but there is no container, there is no variable where this value can be stored. So we have declared a third variable called sum, and it is storing the value of a plus b. Again, that variable sum must be of type integer, because you know that when two integers are added together, the result must be an integer. The addition of 2 plus 4 is always an integer. The again addition of 5 and 10 is always an integer. Any two integer numbers when added together, the result is also an integer. So there is no question about that why sum is declared as integer. So you can do it likewise, or you can declare the third variable in the beginning, like int a comma b comma sum, and here you put simply sum, because you cannot declare the same variable multiple times. So either way you can do it. Either you can type int a comma b comma sum and then put the semicolon. Then in that case, because sum is already declared in this line, you need not have to put that int here before sum. But in my case, in this example, I haven't declared the sum variable earlier. So I have written here, I have declared it in this step, in sum equal to a plus b. Now again printf. So after this step, int sum equal to a plus b, it is still here. Remember, it is still here. It is in the arithmetic logic unit. Now, in the final step, printf the sum is percentage d comma sum. Now, this 2 plus 4 through memory write operation, this result 2 plus 4 must be stored in some location, say in 0, 1 through memory write operation. Now, this address you need not have to specify. Unlike the input variables, you actually mentioned that where it should be given, where it should be stored, but in the output you need not have to specify some explicit address, because whenever 2 plus 4 is given, okay, that result is stored randomly in memory in some arbitrary location. Okay, 6 is the output of this, and after the memory write operation, the control unit will send this data, that is 6, okay, through the data bus, and that 6 will be placed randomly in any location. That location is not specified, it can be any random location where this 6 is placed. And the last step, printf the sum is percentage d. That means here after this 2 plus 4, 6 is already here, okay. And in the last step, the sum is percentage d comma sum. That means again I want to, whatever the sum is there in the RAM, I want to get it printed in my output screen, that is say monitor. So this 6 must be printed. So that is why again I have written that printf statement. You know that percentage d. Why percentage d? Because sum variable itself is again an integer, okay. And the sum is percentage d comma sum. Because why sum? Because the variable name is sum. In case the variable name was c, that is, if I would have written in c equal to a plus b, then in this case the result would have been printf the sum is percentage d comma c, okay. So that ends the program. Now the 6 will be printed in the output unit using this step, and we close down the braces to complete the program. So these are the basic lines. Now let me explain that what is the utility of the semicolons at the end of each line. The semicolons are given to mark the end of the statement, the end of the line, because if we don't put the semicolon, then the compiler will think that this line and this line are the same. So to mark the end of a line, to mark the end of a statement, we have to put the semicolon at the beginning, at the end of each statement, okay. So this is all about these steps. Now I will come to these two lines. Why I have written hash include stdio.h, okay. That means I am including standard input output header file. Stdio means standard, std for standard, io for input output. That means I am including this into my program. Why? Why I am including this into my program? Suppose I am in a library, okay. I am going to a library to get myself with some books on C programming. Now, how will my choice be affected? Say there are many books in C programming by Indian authors, by Western authors, okay, by some American authors. So suppose I want C by Yashwant Kanitkar, I go to the library and search for that book. Okay, if that book is available in the library, then only I can get this. Again, if I suppose I want Carnegie and Ritchie C, but that book is not included in the library, then can I get that book? No, I can't get that book, because our choice is only limited to the books which are available in the library. We cannot get any book which is not present in the library. So when I include a library to a C program, that means whatever functions are included in that library, that can only be accessed from within the program. Now, since I have included the standard input output header file, this is the standard library function which I have included. The standard header file I have included, so I can only access the standard input output functions from this header file. So what are the standard input output functions being used here? See, there are two standard input output functions. One is the printf and another one is the scanf. So standard input output functions within stdio.h header file are printf and scanf in this particular program, obviously. Printf and scanf. So this printf and scanf are the two functions which I have used. I haven't declared them myself, I haven't defined them myself because they are already declared and defined within this header file. I have included this header file and as such it has given me the freedom to call these functions directly from my program. So that is why I can easily, because I have included this header file which is containing all the details about these functions, which is already containing all the details about these functions within the standard input output header file, which the makers of the C programming language have already included within the standard header file. So I can simply call them. So that is the freedom which I have executed because of including this header file. Now printf and scanf are the standard library functions which I have called, and to call them according to my convenience I have included this header file. I hope the concept is clear. Okay, if the concept is not clear, you can always comment in the video, in the comment section, that which part of this lecture you haven't understood, and me and my team will reply to your comments as early as possible. Anyways, so now the last part of this lecture, that why I have declared the void main. Now this is another function. Remember that for any kind of program, okay, you need a main function. For the moment, remember that no C program can execute without a main function, because the compilation of the program begins at main. The program executions begins at main. So each and every program which you will write in your life, okay, they must contain some main function. It is mandated, it is must. So maintaining this rule, we must write a main, okay, and this main function is defined with our statements, because this is the main part of the program. So the body of the program must be included within the main, and the main function begins, you have started the second bracket, the main function ends, you have ended the bracket, or you have closed the braces. So everything which you write within these braces, that is the body of the main function. And remember, for the rest of your life, program execution is not possible without main, since every program execution begins at main. Okay, so see, without main functions, we have already used functions. Okay, the third function which we used is the main function, but the only difference is that the main functions we haven't called, because it is called explicitly by the compiler. We need not have to call it. Okay, we have just defined the main function. But the printf and scanf functions, we did not define them. We have called them from within our program. Why we have had that freedom? Because we already included the standard input output header file, and that standard input output header file has all the function definitions and declarations. So simply we can call them. Now this main function is not returning anything, it is not returning any value. So that is why the return type of the function here is void. In Linux based operating system, in Linux based C compiler like GCC, okay, you will find that the return type of main is int, that is integer, and in case it is int main, then that return statement will be included like int return 0. Okay, So in case I write it as int main, okay, then after the program execution is done, that is after I have written all the statements, I will have to put one extra statement, that is return 0, because now the main function is returning something of type integer, so there must be some return. So I have written here return 0. In case that main is declared as int, it is possible in case you are using some Linux compiler, okay, Linux based compiler or Unix based compiler, but in normal Turbo C or Windows based compiler, okay, you can simply write void main and there is no need to return anything from within the function because the return type is void. That's it. Hopefully you have understand this lecture. In the next lecture I will explain you about what the variables are in details, then we will move into the operators. Okay, so looking forward to see you soon. Thank you.